All right. So it is 1:40. So we will go ahead and get started. Um, I am Trent Peltz, and I'm going to be joined by Angelique Membrido, and we are from the coding school. Um, and yeah, our talk is going to be about exploring emerging technology with CS for New York. So we can just go ahead and get started. So basically, just the run of show for us will be a little bit about who we are, what our program offerings are, and an overview of like the different type of emerging technology that we teach and provide for students and educators. And then yeah, a little bit more in depth about our program offerings and opportunities for engagement. So in terms of who um, we are the coding school, and we are a 501c3 nonprofit, really focused on preparing the next generation for the future work within computer science and emerging technology in general, and workforce through workforce development and just training. So through a variety of different program offerings like workshops, full courses that range from 2 weeks to year-long courses and beyond, and professional learning experiences. TCS really aims to ensure that K through 16 students, as well as educators and people already in the workforce, have access to accessible, supportive, and in-depth STEM education, so they're prepared for the future of work. And basically, we run on the principle of three main pillars, which the first one being that we provide early access to emerging tech education. Historically, as we all know, um, you know, STEM education was only offered at a very high level way, mostly in higher ed. And we have been really working to, provide it from as early as kindergarten. And so, yeah, basically, our second pillar is really to focus on increasing diversity and inclusion in STEM. I know that everyone watching this right now understands um, the issues with DEI in this space specifically. And it's been really, really incredible to see some of the really positive impact we've had, as well as a lot of other organizations in this same area, to really increase this diversity and provide equity for all. Um, and then our third pillar is really to just train the next generation of STEM leaders. So as we'll get into, we've been focusing on emerging technologies in general. So specifically kind of quantum computing, data science, AI, but we really just want to make STEM education accessible for all, to provide a platform for those to be, yeah, the next leaders. So in terms of our initiatives, we really have three main initiatives. One of them being our Qubit by Qubit program, which is a introduction to quantum computing. And this is a very large scale program. We have opportunities for in-person as well as virtual um, training. But yeah, this has been going on for 3 years and has been really impactful in terms of providing education for an intro to quantum, whereas so many people don't really even understand what quantum is. So this has been incredible. And then over the last 2 years, we have started our train program, which is an initiative in machine learning and artificial intelligence. Um, and our third flexibility within this. It's based on and rooted in one-on-one coding education with a mentor and a mentee, students based on their interests and their, any previous training they have. And this has been our longest running program. So in terms of our impact, over the last several years, we have taught over 55,000 students in all 50 states, as well as 125 different countries represented. We've had over 300 different school partners, and 55% of our students are from underrepresented backgrounds. So we're really proud of these stats. Um, our reach and our access to students has only continued to grow between our different partners, and it's been really an incredible journey so far. And in terms of just our general student pathway, students and educators can kind of jump in at any one of these points for the most part, but typically how students get involved is it starts out with an introductory workshop, which are usually 2-week period workshops, and they're intensive to really just introduce students and get them excited about different STEM routes. And then typically a lot of these students continue on to do one of our year-long course options in specifically quantum or AI. And so, yeah, these are 1 to 2 semester 4 credit introduction courses. And then from that point, students have the opportunity to apply to our National High School Research Program, which we'll get more into later, but essentially, really excited students can be paired and put in labs for internship programs and kind of, just shadowing different researchers. And it's a really awesome opportunity for students to get hands-on and learn more about to have internships within large tech organizations like IBM or Google, and any of our other partners. As well as we provide a lot of different 1 to 2 week summer camp program options. So that some of those are in person, some of those are virtual, and they and also the classics that we love to go to, which are quantum, data science, AI, and then kind of overarching within all of this, we really want to make sure that educators and people in the workforce are also given access to this education for either their students or their future work and research. So over the last couple of years, we have provided a lot of professional development for educators and people in the workforce. So these are kind of our different options that we have. So now moving on to our next part of our talk, I'm going to overview on our just emerging technology and what we teach here.
Awesome. Thank you, Trent, for that comprehensive insight into who we are at the coding school. So I'm going to dive a little bit deeper into the essence of our mission, which is bringing emerging technology opportunities to our students. So emerging technologies are really at the forefront of innovation. They're responsible for driving changes and advancements in multiple sectors. So they're really the tools and innovations that will help shape the future of our world, and it's crucial that we understand them and harness their potential effectively. Next slide, please. All right, so we're going to delve into what truly sits at the core of all of these innovative technologies that we're exploring. So we at the Coding School are deeply committed to 2 foundational elements. So that's critical thinking and coding. We view these not just as skills, but really as the keystones for mastering pretty much any form of emerging technology. In every course, our mission goes beyond simply teaching the technology. We're here really to just refine those analytical skills and to help students become proficient in a specific programming language, typically in Python. And it's also about empowering them with the tools and the mindset to be able to navigate, understand, and innovate in this tech world. Next, please. Yeah, so we utilize these revolutionary technologies pretty much as avenues, as mediums to teach these essential skills and to provide students with a richer contextual understanding of the evolving world around them. And it's not just about learning the tech, but also understanding its implications and applications in our world. So let's take our Introduction to Quantum Computing course, for example. Even if a student decides that they want to explore other fields, the foundational skills and experiences that they accumulate during the course, they're pretty invaluable. They're transferable skills. And they walk away with a toolkit and perspective that can unlock numerous opportunities and pathways in various numbers of domains. Next, please. So in essence, our approach is about equipping students with a foundational and versatile skill set and a forward-thinking mindset. So again, we're just using these technologies as a medium, and it's this combination that will really allow students to thrive and innovate regardless of the specific technological landscape that they choose to immerse themselves in the future. Next, please. So the landscape of emerging tech. So emerging tech is a pretty broad term. It's this big umbrella covering a whole array of innovations. So I'm going to run through a couple of examples here just to give you a quick snapshot. And Trent, we can load all the examples on this slide. AI, this is about creating intelligent machines that can learn and make decisions. So it's really about exploring the possibilities of what machines can do and then pushing those boundaries. Quantum computing, this is really about tapping into advanced computing technologies. So we're trying to explore new realms of processing and solving complex problems at pretty phenomenal speeds. Next up, we have biotech, and this is where technology meets biology. So leveraging tech to understand and solve problems related to living organisms. So this is the science that's shaping the future of health, the future of medicine, agriculture, and so much more. There's also crypto and blockchain, so reshaping the world of finance and beyond. So aiming to create a decentralized and secure way to manage assets and data. There's also the Internet of Things, or IoT, all about connecting everyday objects around us to the internet. So you can kind of imagine like your fridge sending you a text when you're out of milk. And then finally, we have augmented and virtual reality, so AR and VR. And these fields really transform the way we experience the world around us. So it's kind of like we're stepping into this new dimension where the digital and physical world collide. So each of these fields, they're all like pieces of the emerging tech puzzle. They all offer new perspectives, solutions, and possibilities that are changing the way that we interact with the world and the way that we interact with each other. So by exploring, understanding, and leveraging some of these landscapes in our courses, we're preparing our students to be the innovators in these exciting realms of technology. Next slide, please. So we're going to hone in just a little bit. We can load the rest of this slide as well. But basically, amongst the vast spectrum of emerging tech, at the coding school, we are particularly stoked about two pretty big game changers. So AI and machine learning, and then quantum computing. So first off, just to begin with AI and ML, it's not just an innovation in itself. It's kind of like the heartbeat of most other emerging technologies. So diving into these topics, our students have the opportunity to grasp core techniques, the kind of stuff that they can whip out later on for loads of future opportunities. Then we also have quantum computing, and this is kind of like the new kid on the tech block, still in its youth compared to the others. And there's a lot of untapped potential here. The students that we're nurturing today, they could be the ones defining the ethics and the principles of this field tomorrow. And quantum computing teaches them to approach problems and think in ways that are quantum. It's like learning to think in multiple dimensions at once. So here at the coding school, we're pretty much focused on AI and quantum computing. And the reason why is because we see these fields as really the catalysts for future innovations. So the epicenters of learning that will really empower our students to apply foundational skills and ethical principles to a wide variety of opportunities and challenges. So keep in mind, we're not just teaching tech, we're molding the innovators who will redefine what's possible in these domains. Next slide, please. Okay, so speaking of empowering innovators, I'm going to transition to something that we're really proud of, which is our Train Machine Learning course. So this course is meticulously designed to offer students a rich, immersive experience into the realms of AI. So really paving the way for them to explore, create, and contribute to the field. So we're going to delve a bit into what makes Train so special and how it stands really as a beacon of our commitment to excellence in tech education. Next slide, please. All right, so we've all heard the term machine learning tossed around in news headlines, maybe on social media, podcasts, Terminator. And it's really like this big, shiny buzzword that seems to be popping up everywhere you turn. Next slide, please. And the reason why is because machine learning is quite literally all around us. So we can run through the examples on this slide. You might have heard about machines recommending the next TV show that you should binge watch. We can go through all of them, Trent, but there are some other examples. So controlling autonomous self-driving vehicles. And then finally, we have predicting the weather. So it's really like this wave of intelligent machines taking the world by storm. Next, please. Yeah, so what's the real scoop behind all of this buzz? What is machine learning actually? So we're going to peel back the layers and just take a peek at what's going on under the hood of this pretty groundbreaking technology. Next slide, please. So we're going to start off with some definitions. So let's start with artificial intelligence, AI. This is basically the science of making machines intelligent. So you're crafting cool technology that can mimic human thinking and behavior. And the key questions here that we're asking are, how can we make our machines smart? How can we get them to think and act like humans, like us? Next, please. So within this world of AI, there's a special nook called machine learning, or ML. Sometimes people use these terms interchangeably, but ML is really a subfield that's all about teaching machines to learn on their own, without us having to spoon feed them every step of the way. So the big question that ML is tackling is, how can we make our machines learn from experience while simultaneously getting better and getting smarter on their own? Next slide, please. All right, so now that we kind of have a grip on what machine learning is, we're going to talk about where we see it in action in our day-to-day lives. So first up, image recognition. So it's teaching machines how to see and understand visual input. So you can think of like Facebook tagging you in photos. So that's machine learning at play. Then we also have speech recognition. This is the magic behind voice assistants like Siri and Alexa, understanding what you're saying. So it's giving ears to your machines. And if you can hear that in the background, that's, I guess I turned on my own Alexa by mentioning. But then we have fraud detection. So machine learning is the detective that spots unusual activity in your bank account and alerts you. So it's like having a security guard for your finances. The most classic example, probably self-driving cars. Machine learning helps cars make sense of their surroundings and make decisions on the fly. So that's a little bit of giving your car eyes, as well as giving the wheels a brain. And then we also have product recommendation. So if you've ever wondered how Netflix knows you so well, that's machine learning analyzing your preferences and then suggesting what you may like. And then last but not least, we have traffic prediction. So thanks to machine learning, apps like Google Maps can predict traffic and suggest the fastest route. So yeah, these are just a few examples. Machine learning is kind of like, I like to think of it as like an invisible force, and it's like quietly powering all of these innovations, making our lives smoother, smarter, and more connected. And of course, it's only going to grow from here. Next slide, please. So machine learning is like this invisible hand reshaping whole industries, tweaking the way they operate and innovate. So we can run through the entire slide, but basically it has its applications in the field of transportation, where it's optimizing routes and fuel efficiency. We also have healthcare, so making diagnostics and treatment more precise. And finally, we have finance, so predicting market trends and assessing risks. Machine learning is pretty much everywhere. So why is this cool for our students? So the beauty of learning machine learning is that it's not about the one thing that you can do with it. It's about a multitude of doors it opens up. So the skills and knowledge acquired, they aren't bound to a single application or a single industry. It's like learning the language of the future. Once you know it, you can converse in any field that you're passionate about. And it really empowers our students to take their learnings and apply them wherever their curiosity and passion lead them. And that really is what makes them the architects of tomorrow's innovations. Next slide, please. So I'm just going to quickly visualize how all of these fields are interconnected with this diagram. So you can kind of picture this. We have artificial intelligence, AI. That's this massive umbrella. It's the grand idea of machines mimicking human intelligence. Within that field of AI, we have machine learning. And that's really a subset where we teach machines to learn from experience. So to get better and smarter without being explicitly programmed to do so. And then within machine learning, there's a sweet spot called deep learning. And this is where machines learn from artificial neural networks, which are really meant to mimic biological neural networks, so our human brain's architecture and functioning. And deep learning is what really allows our machines to learn from large amounts of data, so really big data. And speaking of data, all of these domains are intimately intertwined with data science, which is the field focusing on extracting insights from complex and unstructured data. Data science really serves as like the backbone to all of these fields. It's what really allows them to analyze, learn, and evolve. So you can think of it as like the art and science of transforming data into actionable knowledge. And a good question to think of is, why is this blend crucial for our students? Diving into this course isn't just about understanding AI. It's also a journey into the essentials of data science, which is a growing field itself. So our students walk away with substantial exposure to this pretty expansive field, and they're gaining insights into how to use or how data can be used to create, innovate, and solve problems. And it's kind of like giving them a sneak peek into all of the opportunities that really open up when you know how to converse with data. And that allows them to explore various pathways in this pretty dynamic ecosystem. Next slide, please. So what types of machine learning are there? So machine learning is actually a pretty broad term. This can be categorized into a couple different types of learning. Next slide, please. So diving deeper into machine learning, we actually encounter three main categories, each with its unique approach and application. So first up, we have supervised learning. Here, a good analogy is, think of like giving your computer a textbook with all of the answers, and you're providing it with the data, and you're explicitly saying, okay, this is the input and this is the expected output. If you receive this input, you have to be able to reach these conclusions. It's like teaching a child addition by showing them that 1 + 1 = 2. So they learn from the provided data, and it builds all of these connections that it's then able to apply to new unseen data. Next up, we have unsupervised learning. And this is where things get a little bit more mysterious. We give the computer data, but no specific instructions on what to do with it. It's kind of like tossing someone into a room full of puzzle pieces and then watching them figure out how to piece them together. You're trying to find hidden patterns and relationships. So it's really all about discovery. And then last but not least, we have reinforcement learning. So this one's pretty cool. It's like learning by trial and error. So we have, let's say, an intelligent agent, a model that explores and learns by interacting with its environment. And in doing so, it'll receive either rewards or penalties. And based on those rewards and penalties, it will adjust its strategy accordingly. So it's kind of like training a dog. If your dog sits, they get a treat. So that's pretty much what reinforcement learning tries to emulate. And here's the cool part for our students. By navigating through these types of machine learning, they gain insights into diverse approaches to problem solving, to learning, both in machines and, interestingly enough, in us humans. So it's like equipping them with multiple lenses to view and interpret the world of both data and learning. Next slide, please. So while we delve into the variety of possibilities that machine learning offers, our courses predominantly focus on supervised learning. Students do get a good amount of exposure to unsupervised and reinforcement learning. But we really believe that by guiding our students through the structured world of supervised learning, we lay down a solid foundation for them. So it's like giving them a well-defined playground to understand the basics. And this foundational knowledge then becomes their stepping stones to explore and grasp more complex, uncharted territories of machine learning. So we go into pretty advanced topics. We go into image classification, deep learning, natural language processing. So yeah, next slide, please. So now that we've kind of dipped our toes into the vast ocean of machine learning, you might be wondering, how do we bring all of this to life? So how do we craft these learning experiences and actually create this technological magic? Next slide, please. So to create meaningful outcomes and predictions in machine learning, we adhere to a structured process. So we can run through all of these steps here. It basically begins with collecting raw data, which is the essential foundation of any machine learning project. And then this raw data is meticulously prepared and organized in order to be processed effectively. Something that we really emphasize at the coding school is the quality of our data determines the quality of our model's predictions. And in industry and practice, the data preparation stage is actually the most time consuming. Then we select an appropriate model based on the nature of our data and the problem at hand. So students encounter a variety of different algorithms in this course, and they learn that different algorithms serve different purposes. So domain knowledge, understanding your project goals, these are really essential in order to select the right algorithm for your problem. Once you select your model, you then train it using your prepared data. And it's just allowing your model to learn how to make predictions or how to make classifications. Finally, we get to the stage of validating and improving our model, so ensuring its accuracy and reliability in producing desired outcomes. Next, please. Yeah, so once we've reached a level of optimization that we're happy with, then we can deploy our model to make real predictions and inferences. Next, please. Yeah, so this entire process that you see, it's a lot of information that I'm throwing at you all at once, but it's an iterative process, meaning you will more often than not have to go back and forth between certain steps. And we go into a great amount of depth with our students for each step. They're taught plenty of different strategies and techniques. Students are taught how to make adjustments based on the performance of their models, and they're taught to really strive for peak optimization. This entire process is also driven by data. So data is the fuel that really powers machine learning, and it enables us to derive insights and make informed decisions. Next slide, please. Yeah, so data drives machine learning. Okay, so an essential principle that we instill in our students is that models are only as robust and as accurate as the data that they are trained on. We can load this whole slide, but it doesn't matter how sophisticated or advanced a model is, its reliability and performance are fundamentally anchored to the quality of the training data. And this is why a substantial portion of our teaching is concentrated on preparing and analyzing data meticulously. So we guide our students to understand, to clean, and transform data to ensure that the models that they build are grounded in reliability and precision. Next, please. Yeah, so in essence, data isn't just a component of machine learning, it's really the heartbeat, the core that determines the success of any machine learning endeavor. Next slide, please. So the principle of garbage in, garbage out is crucial in machine learning. I think it does a great job of illustrating that if your input, your data is flawed or garbage, the output, the results of your model will inevitably also be flawed. And this isn't just about inputting biased or inaccurate data. It's about every step of that data processing and preparation phase. So from how the data is cleaned, how the data is collected, to how features are selected. Any step of this process can introduce bias or errors, and that really affects the reliability and impartiality of the model. And because if we use biased or erroneous data, the model will really reflect those biases and errors. So that's why we emphasize to our students how important data analysis and preparation are. We tell our students, we teach them how to be super mindful and vigilant at every step to minimize biases and errors, ensuring that the models that they create are not just accurate, but also fair and equitable. Next slide, please. Okay, so machine learning, while revolutionary, it's not without its set of challenges. And we try to mitigate a lot of these problems through the content that we deliver. First, we grapple with issues related to data quality and availability. So this requires a delicate balance. So acquiring extensive representative data while still respecting individuals' privacy rights and navigating the intricate landscape of data ownership and consent. Second, there's the challenge of interpretability and explainability. So understanding and elucidating how a model makes decisions is crucial. It's about creating transparency. It's about building trust between the ML community and non-professionals, and then ensuring accountability in the models that we develop. There have been plenty of harmful implications of models that were trained on biased data, which is something that we really try to mitigate. So a lot of the time, especially with these artificial neural networks, we're throwing a bunch of data into our models and it's spitting out these predictions, but we're not always sure how our models reach those conclusions. It's like this black box and that's what we're trying to elucidate as much as possible. When you think about the human brain, there's so much about the human brain that we don't know. And it's just like that with artificial neural networks as well. At the end of the day, machine learning isn't magic. It's learning from data. But because of that disconnect between machine learning professionals and then non-professionals, we really need to address the lack of explainability that a lot of these models exhibit. So addressing this concern will also contribute to a greater trust in machine learning models. And then thirdly, we have privacy and security. These are of paramount importance as well. We're tasked with protecting sensitive information against a myriad of threats. So just ensuring the integrity and the confidentiality of the data that we handle. Another significant hurdle is generalization. So models need to be robust and versatile. Maybe a model performs really well in the training phase, but then it's exposed to new data and it doesn't perform as well. It's not as accurate. So we really want our models to perform accurately on unseen novel data, adapting to new information without compromising its reliability. Lastly, ethics and bias are at the forefront of our concerns. So establishing and adhering to ethical norms is non-negotiable. At the coding school, we talk about bias, machine learning ethics, and how to actually quantify bias. So we're trying to foster fairness, we're trying to mitigate biases, and really ensure that the technology we develop is equitable and doesn't perpetuate harmful stereotypes or inequalities. At the beginning of our courses, we emphasize we're delivering a lot of this new groundbreaking technological education, but knowledge is power. So we hope that the students that we train walk away from this course with all of this knowledge, but they use it in a way that benefits society. Something we really emphasize at the coding school is that addressing these challenges is not just crucial, it's imperative. As we navigate the evolving landscapes of machine learning, it's important to also prioritize ethical use of technology. So we're not just developing technology, we're shaping the tools and platforms that have profound implications on society, on our economy, on individuals themselves. So We're really trying to foster a future where machine learning is not just advanced, but also equitable, responsible, and transparent. Next slide, please. Yeah, so what we've learned today, what we've explored today is merely the tip of the iceberg of what we teach at the coding school. I can't fit 2 semesters worth of content into 30 minutes, but we delve deep through the multifaceted dimensions of different transformative technologies. This is only one course that we offer. We have a super interesting, very, very well developed quantum computing course as well. But both work hand in hand to ensure that students emerge with knowledge and skills that are comprehensive and also applicable. And with that, I'm going to hand it back over to Trent, who's going to give you a more detailed overview of the range of the programs that we offer and how they are designed to equip our students for the future. Over to you, Trent.
Awesome. Well, thank you so much, Angelique, for that. Great overview of ML and our just general artificial intelligence offerings. So yeah, I will go a little bit more in depth about our different program offerings and what these look like. So yeah, one of our different options that we have are in-person summer camps, even though we are historically and largely a virtual foundation organization, and most of our students are joining us from a virtual setting. We do really want to make sure that there are in-person opportunities for students to really gain excitement. For a lot of non-historically STEM excited students, these in-person opportunities are often what get students excited. And so these are just a couple of our previous in-person summer camps. One at the University of Arizona, also partnered with the Girl Scouts of Southern Arizona. This was a female-led, female participant-only summer camp in quantum. And these students actually got to work within quantum labs and really have a hands-on experience. Similarly, we had another incredible program partnered with Cleveland State University, also in quantum. And this was a co-ed program that similarly had students, working hands-on on different quantum, applications and research projects within labs. So. And then our two largest program offerings are our 2-semester year-long courses in quantum computing and AI and machine learning. So these historically have taught over 2,000 students annually, and also kind of continues to grow over each year that we do it. And we're really, really proud of our stats in terms of continuing with STEM, getting kids excited for STEM. So these are just a few different stat lines. So from these past 3 years in particular, 90% of our students report an increase in confidence in their STEM skills after taking either one of these year-long courses. 82% of students are interested in pursuing a career in STEM after taking this course, whether they were interested or not previously. And then 83% of students report that this course increased their sense of belonging in STEM. So at the root of everything we do at the coding school, we really, really want to, empower students, especially those who have historically felt underrepresented or, daunted by trying to find a place within STEM. And, that stat alone really shows that we've done a pretty awesome job at creating a really supportive and kind of family-esque environment for these students to feel belonging in. And yeah, so in terms of our actual course components, there's kind of 4 main components that each of our courses or workshops are comprised of. So mainly we have live lectures in which students are led by a lead instructor who is either a PhD student or has their own lab that they work in, or they are just in the workforce already. And these are essentially 1 to 3 hour lectures in which students, get to ask questions and whatnot, but it's largely, a instructor-led lecture. And then students weekly or bi-weekly sometimes will split up into group labs in which they're much smaller groups and they get to really exercise the concepts that they learn about in lectures. So these are led by our TAs, and these are much more hands-on and interactive. And then from there, we have homework assignments, everyone's favorite part. And these are, yeah, also hands-on learning experiences that, are given out throughout the course, and students have a lot of availability or ability to, have support from TAs and throughout this entire process, such as, office hours and things like that. And then, yeah, as I just mentioned, there's a lot of opportunities for student support throughout their courses so that no student, feels like they're kind of left behind, or, other students are going way further ahead at a way faster speed. Obviously, these can be really daunting topics, especially to younger students or students who have no, technical background. So we really, really want to always make sure that students feel supported, and that there's enough opportunities for students to feel this way, free of judgment. Whereas like classroom settings can often cast a lot of feelings of judgment or insecurity, on students. So these are a couple pictures on the left of what some of these courses look like in terms of just having a lot of students in a Zoom call, and yeah, they look very happy. So yeah, in terms of offering support for our students, we have a lot of general support, offerings and office hours, but we also have, affinity groups for students, join other students of shared identities. And so, students really gain a sense of belonging, as we've mentioned throughout this talk. And we think that's really important, and it's worked really, really well for students just like have a safe space and to talk openly and grow really incredible bonds and relationships with their mentors and instructors as well. More generally, we have support sessions that specifically will go over topics like their homework, logistic things. And yeah, we have those multiple times every week. And then my favorite part, and some of the most exciting opportunities we have that makes the coding school really special, is our access to a variety of guests within each of these fields. And these can range from, top tier leadership members within, the largest tech companies in the world, from IBM or Google or Microsoft, or, leading researchers in these fields at quantum labs, or, machine learning scientists and data scientists. And also, we've had people that are CEOs of new, new AI startups and things like that. So these have been really, really exciting opportunities for students to, see where they could end up in this field, and see, the prospects that lie ahead of either studying these things or just getting involved, or just what we can do from a practical standpoint by learning these fields. So these are incredible, and we try to pack in as many of these guest lectures and talks as we can, and give students as much opportunity to engage and talk with these visitors as well. So another thing that we kind of set out on a couple of years ago that I think has been absolutely incredible is giving a select number of students, specifically from our quantum program, the opportunity to have a summer internship within a quantum lab. And so this is kind of an unheard of thing prior to this program, but it's been really incredible. Essentially, a lot of different partner universities that have quantum research facilities have, taken in 1 to 3 different students of ours that are highly interested and highly engaged students within our programs, to really just kind of shadow them and come up with their own quantum research projects in within this summer program. Um, I sat in and moderated our last, capstone project presentation, session for these students just a few weeks ago, and it was truly one of the most mind-blowing things I've ever witnessed. Seeing these high school students, some in 10th grade, some rising seniors, um, you know, just share about concepts that I barely even know about or have heard about. And the things they accomplished in just a summer period were absolutely incredible. So this is something that I know everyone at the coding school is really looking forward to continuing and seeing the incredible results from. So a lot of these students will most likely go on to, work within a large organization doing quantum research, or at at somewhere like IBM or Google. So yeah, similarly, we have in partnership with Columbia University's Data Science Institute, we have a summer data science research program. And this is just an intensive training in data science and developing just skills in R, programming language, data visualizations, data cleaning, data analysis, and much more. So as Angelique mentioned, good data is what drives our ability to get good results within any of these emerging technology fields. And so it's really, really important that students understand how to get to that point of organizing data, cleaning it, and getting the best results they possibly can. So this has been an incredible mentor-mentee based program. And as you can see, there's some incredible stats that come along with our students from this program. 98% of students are likely to major in a STEM subject in college after doing this program. 93% of students felt way more confident in their coding and research skills. And specifically, New York students are paid through the Summer Youth Employment Program. So it's really just been an incredible opportunity to provide studies and more research in data science for students. And then, as I mentioned at the very beginning, over the last couple of years, we historically were always K through 12, sometimes had offerings for university students, and what we realized is that we really wanted to provide access to our education for educators to bring this into their schools, as well as for people in the workforce to really have an understanding of this as they start to use a lot more applications in these fields, to just get better and better results and more efficient processes. So, historically, we offer these to educators from middle schools to universities. And we really just have a computer science first learning approach where we think everyone should have this basic understanding of computer science. You'd be surprised, even with the growth of computer science course offerings in high schools and even middle schools, there are so many schools that don't even begin to touch emerging technologies in their curriculum. And so this has been an incredible expansion of our accessibility offerings, where we've had so many teachers and just incredible testimonials about just how much this enhanced students' learning experiences and their opportunities for growth outside of school. So basically, these PDs have historically ranged, in size and intensity. So some have been 2-week intensives, some have been 4-week intensives. There's a very large range of depth of knowledge in terms of like where people are coming from, what we specifically hone in on and teach in these professional development courses. We've offered in-person ones, virtual ones, and yeah, there's really no coding experience. So we've had teachers in just historically math backgrounds, general science backgrounds come in, even some liberal arts background teachers have just come in and wanted to learn about this and incorporate it in their own curriculum. So it's been really an incredible expansion. So just to walk through a few testimonials from our students, I'll just read through some of these. So one of our trained students, Skylar, who was a ninth grader from Arizona, says, "This AI course has opened my eyes to the many opportunities that await me in the future. It went above and beyond. The people, the effort, the topic itself, it was all executed well, and it can change you forever." It's pretty incredible. Another trained student, Roger, said, "After taking Intro to AI, I hope to attend college and study computer science to best tackle the issues of racial and ethical biases in the growing field of AI." From Jade, a quantum student, "This year of learning quantum computing changed my college plans. This course cemented my love for physics and has made me pivot to pursue this in higher education through undergrad, through a master's, and even a PhD." And one more quantum student said, "This program has had a personal impact on me and my future plans. Personally, I've realized that I am an experimentalist and that I like to do research. This program has also encouraged and convinced me to join this quantum computing lab." So this is one of our participants in the high school research program. So, and then we kind of operate on just these few best practices. So we think, and our data shows that near peer instructors provide students with the most inspiration and excitement. So we like to, have college students teaching high school students, and you know anything like that that's really near peer, and students can see that direct impact and inspiration for what they could be going forward. And we've seen a lot of incredible relationships that have continued beyond our just our courses develop with these near peer instructors and students. So as I've kind of mentioned, virtual programs historically work for students who are already STEM inclined. So most of our students that come in have some sort of understanding, or are excited about quantum or AI because they read a book or they watched a YouTube video. And they're the more likely to continue onward from our virtual programs. And then in-person programs are great for really, really inciting that excitement for students who really either don't have any previous knowledge, who are sometimes just forced by parents to join something like this extracurricularly. And yeah, we've seen a lot of great continuation stats for students like that. And then ideally, we want to make these programs accessible to everyone, and we never want to turn away people who are extremely excited and should have access to these programs. So most of our programs are free. We do this often through a lot of sponsorships or partnerships, as well as a lot of school to the coding school partner relationships. So, and then in general, I'll just go over a couple different opportunities for engagement and how you can get involved, and other people can get involved. So we started this awesome program in sponsorship with and partnership with Keysight, called Into the Quantum World Workshops. And these are kind of just really getting students at the very foundation, just some basic understanding of what quantum is. So everything from quantum mechanics concepts to just basic quantum circuitry, and some physics basics. And so these can really be in person, virtual. It can kind of be that initial bridge into, wanting to know more about, quantum and our different other program offerings. So we've had tons of different, colleges as well as high schools bring these little workshops into their schools. And we've had awesome success in terms of them inciting excitement for students and doing more programs with us. And then in terms of becoming a school partner, just in 2023 alone, we've had nearly 120 school partners, because our programs are uniquely WASC accredited. We can get students school credit with our programs, and that is very unique for especially quantum and AI. And so we've seen this be done in terms of school partners offering our programs as independent study electives within their school day, adding an actual course slot into their curriculum. And also we've seen it done as like a supervised after school program, as well as sometimes just students do it on their own. And then here's one of our assistant principals in Maryland. He said, coding school has taken a mysterious, futuristic, complex subject and made it clear and accessible. Students say the pacing, workload, and engaging lectures are perfect for them. I'm grateful that TCS made it so easy to enroll and support students. So this has been an incredible thing that we're really proud of, that so many students are receiving credit for this course. And it's really helping them, graduate and get excited about STEM. So that is the end of our talk. I know I went a little bit over, so we only have a couple minutes for any questions, but I'll leave this up. If anyone has any follow-up questions at all or wants to get involved, please feel free to reach out to us. Here's our emails and our social media links. So yeah, I can open up for any questions if anyone has any.